All right, guys. So we're gonna answer that question here. So basically, for these two questions, like that could be your practice exam, right? Spending 4 hours on these two questions, that could be a good first time exam experience. And we kind of just did that, right? Saved a bit of time. And question two, okay. See, if you're kind of preparing randomly, you would expect to be able to solve question two, having done the preparation, okay? And this happened yesterday exactly, all right, with the year 9 and year 8 students, okay? They couldn't solve question two, okay? And it's not that like I mean the question wasn't straightforward, yeah?
Yeah.
But they could still solve it. It's just that they didn't really understand what they were getting into, right? They thought that so what the year 9 student, they thought it was because they were dumb. They couldn't figure it out and didn't respect the question at all. And then just never really like engaged in mathematical thinking skills to solve the problem. It was just all emotional. There's all emotional damage for this person. Okay.
Emotional damage.
Okay.
Is what you
And then the other person who was more like cool, calm, and collected. So the year 9 student who actually came first in ATT in like Australia could not solve this question. Okay. Because they were already not very confident with bases. You see.
Yeah.
So this is it tells you a lot of things about these exam conditions. Okay. So exam conditions, so stressful conditions bring out very predictable behaviors from people. Okay, so if you have a routine question, so something routine is like, for example, being able to write something in another base. Yeah, just like a formula. Yeah, something routine. If you're already good at that, like if you already know how to do it, you'll actually get a boost. You'll be better at doing it under stress. Okay, kind of like in basketball, it's easier to make layups under stress if you're already good at making layups. You actually make it in more often. Or maybe in netball, if you're under stress and you're good at shooting it in, you actually shoot it more, like you're more focused, right? But it goes the other way too. If you're actually not good at it, it exposes you big time, okay? So this guy panicked, yeah, because he couldn't do bases, yeah? And that'll bring out that effect in you. It's predictably, okay? So you can think about what you can do about that. So if you're aware of the effect, obviously you're more in control, okay? And then there's non-routine stuff. Okay, non-routine stuff is like it's kind of like maybe creative writing or something like you really don't know how it's gonna go until you actually do it, right? That gets worse for everyone under exam conditions. Okay, and so this is why like if you're actually trying to solve all 10 questions, you might want to solve like the first because the first two you'd consider to be routine. Okay, you'd try to solve these like earlier ones in like a few minutes. Like it's not very long, okay? And then you leave yourself a lot of time for the one you don't know how it's gonna go. And that kind of simulates a non-stressful situation for you to kind of engage creatively with the problem, right?
So probably if I didn't have enough time right at the end, I could just write some random like explanation for 992 for question two and still get 1 mark.
Yeah, I think if you got 992, you get 1 mark. If you got some kind of working, yeah, because that's a common like it's almost like a typo if you think about how the process goes for the question. Um, and also, like, if you're running out of time, it's probably more likely you can salvage the earlier questions under time pressure than it is to salvage the later questions, right? Because the earlier ones are more routine. That applies to like every single test you'll ever do in your life, okay? So that's kind of very valuable. And then, um, yeah, but the thing with this question, okay, and the issue that actually made people not get the question too, okay, so in some cases they actually didn't even know what basics was, okay, which was pretty bad. But the smart students, they ran into the trouble of which what does interpreting basics mean, right?
Yeah, the
Okay.
two interpretations.
Yeah. So not people not necessarily even saw that there were two interpretations. They just couldn't even like they looked at the phrase and it just didn't mean anything to them, you know? But they didn't even get to the level where the reason it didn't mean anything to them was because there are two interpretations.
Probably in a real exam, if I was doing this, I might have actually gone with the second one, the second explanation.
Yeah. So that's the risk, right? So actually, I had a student in year. So the very first time I taught, so I was like the only non-student to ever teach the maths morning class at James Drew's, the Olympiad class, right? And I had two really good students. One of them was in year 8 and got 34 out of 35 for the exam. Okay, so he got into the national program, whatever. Okay, then I stopped teaching him the next year because I left. Um, and he did this test again. Okay, he didn't solve question 2 in year 9. Okay, and he didn't do very well overall. And he spent 90 minutes on question 2
You should have
trying to
just
figure out what interpreting base 6 what do you want? Okay, so what interpreting base 6 means, what interpreting base 7 means. Yeah, and that shows a lack of preparation. Does that make sense? So like if you think about it, it's like if your question is he not talented enough? Like obviously not, right? He is talented enough. He's done it before even, right? It's like all those questions are actually answered, and the real reason is just not enough preparation, and they're not really understanding where you're at relative to the question, and and also maybe not having sort of this extra thinking skill to solve the problem. Yeah. So the reason it can't be the second interpretation is because the number doesn't change in the second interpretation, right? You know what I mean? Like you can rewrite the number, but it's still the same number. Yeah. So then you get 4x equals like 3x plus 2 or something like that, right? And then x equals.
When I tried it and tried to multiply it by 4, it kept on getting out of base 6 for some reason.
So you end up with a number that's not 3 digits. Okay.
Yeah.
So it can't be the second interpretation. And that was a difficult problem for people who had to actually solve it because they had to come up with the problem too, right? It's easier just to go with the first interpretation, okay? When you go with the first interpretation, I mean, it's still not trivial, okay? It's still kind of like the first question still, right? Okay, so what am I talking about here? So you have a number like A, B, C, right? And obviously, I'm writing ABC to show you the general case, but as young beginners, you've got to be trying actual numbers, okay? Even if you know how to do it this way, I think the fact that you could get the whole answer in the first test case is enough justification to try a single number before doing this. Does that make sense? And a lot of the time, it actually limits a lot, okay? So, for example, the first number you try, because you're like it's looking for the maximum number, right?
Yeah.
If the first number you try is like 900 something, right?
Yeah.
That might expose that error with the digit 9 right off the bat, right? Does that make sense?
So you wouldn't have 9, you wouldn't have 8, so you would have to have 5 something.
Yeah, and making that observation is much easier when you actually try with the 900, right? Than to think about it abstractly, right? Okay, so ABC, so this is like intrinsically base 10, right? And then we're converting it into ABC base 6, right? And then we're converting that into ABC base 7, and then we're kind of timesing this by 4, we're timesing this by 3 and plus 2, and then we're equating them, right? So if you write them out in symbols, it's kind of obvious. So what does base 6 mean here, right? So this is A times 6 squared, which is 36 times A, B times 6, which is 6B, and it's C times just C by itself, right?
Yeah.
And you're timesing this by 4. Okay. And then here it's the same thing but with 7, so it's 49A instead of, it's 49A plus 7B plus C times 3 plus 2, right? Okay. So
Wait, but then I had the right equation.
yeah.
But somehow it turned up with 9, since I didn't really know that 9 didn't work as a digit.
Yeah.
So just put 9 down.
Yeah, I think I'll show you. I can kind of guess Benchen's thought process. Okay, so okay, Yanni. Yep.
I think someone's in that waiting room.
Waiting room. Who's in the waiting room?
Oh. Okay.
Okay, so this once you got this equation, okay, the next step you would almost do kind of like it's purely technique, yeah. It's a routine. You would simplify the equation, yeah.
Yep.
This is almost just kind of like just writing it neat enough so you can read it. Basically, it's a very it's a very natural step. So you would, for example, like the 4c, you would subtract 3c from both sides, and you'd have c, right?
Yeah.
Okay, so it's like 49a plus 7b times 3, yeah, plus 2 equals 36a plus 6b times 4
Plus a C.
plus c, right? Okay. And can you see what to do next? It's kind of the same kind of thing.
4B.
You just do the same thing for A's and B, right? And so I don't know if you'll appreciate this now, but I feel like instinctively I would not. I don't know. I don't know if which one's easier for you. Would you times 3 by 49 and minus it from 4 times like do you make the big numbers or not? Like I would always factorize it, but maybe sometimes if you're starting, it might be just simpler to do like 147 and 144 and you get 3. Yeah. But I might do like 3 times 49 here, and I will do like 3 times 12 times 4 here. So then it's 48 minus 49, so it's just, so there's 3 A's, yeah?
Yeah.
And there's 3 A's on the left-hand side, yeah? There's 3 A's, okay, plus 7 times 3B plus 2 equals 6 times 4B plus C, yeah? Okay, so now there's 21 B's here,
And
yeah?
24.
24 B's here, yeah? So then that's 3 B's, yeah? So you get 3A minus 3B um uh
Equals plus 2.
plus 2 equals C, right? Okay. So um so remember we did simultaneous equations last week? Okay. Just kind of knowing stuff like that helps you think about an equation like this.
You
Yeah?
could just substitute it in.
Yeah. So basically you have one equation and 3 unknowns, right? So obviously that's not enough to find out any of the variables, yeah? But it's always going to be enough to eliminate one of the variables.
Yeah.
And so because you can write C in terms of A and B, okay, the A and B can literally be anything that satisfies the conditions, and then C will be determined. Yeah. And so this is where I'd imagine Ben Chung got the 992 from. Because if you make A and B the same, right, the biggest possible is 9 and 9. You get C equals 2. That's 992.
Yeah.
Yeah. Okay. And so all he had to do was realize, okay, the biggest is actually 5. So we do 5, and it's 5 times.
So
Yeah.
you can't really use 9.
Yeah, you can't use 9.
Yep.
Yeah, so 9, it doesn't make sense to interpret the 9. Like, it doesn't follow the same formula anyway. Yeah.
Yep.
To interpret the 9 in basics, you have to deal with what 9 even meant. Because 9 is bigger than 6. You know?
9 doesn't even exist.
Yeah. Okay, so if you get here, basically you're allowed to make A and B whatever you want and C is determined. So obviously you want to make A and B big, right? Okay. And so if you actually thought about that, okay, so now if you think about it, what is the value of actually understanding the question and guessing? Okay. If you knew, as Daniel already said at the very start, right? If you listen to Daniel at the very start, it can't be more than 5, right? Then the biggest number is 555, right? If you proceed to guess, obviously you would guess from you would guess from 555 down, right?
You would only take 4 guesses.
It would only take you 4 guesses to get to the answer, okay?
All
right.
But I think that's quite risky, since if it was like,
Oh yeah, obviously it's very risky, but it's always it's I mean the point I'm trying to make is like you gotta create your chances somehow, right? If you're just giving up and going home, right? You could have guessed 4 things and gotten the opposite of giving up and going home, right? It's like solving it and going on a flight to the Australian team camp or something. You know what I'm saying? Like, yeah. So a lot of people who succeed, they weren't guaranteed to succeed. You understand? No one's guaranteed to succeed, but you got to create your chances. Okay. All right. All right. I'll show you the statistics. Okay. Try to forget these for the other questions, but this happens pretty much all the time. Okay. There's roughly 2,000 people that do the test.
What
Okay.
is wrong with question 2?
Yeah. Well, question 2 was a statistical anomaly for the reasons I've already mentioned. Okay. Basically, question 2 was done almost as bad as like question 7 and 8 were the only ones in the first 8 that were harder to get than question 2
Did anyone get full marks?
in the whole test.
Yeah.
Oh, actually, this was the year where we had literally like this year we had literally 4 students in our whole school, and 3 of them got prizes. But they were all like it was 2 year 10s and 1 year 9. Haibing was one of the year 10s. This was Haibing's year 10 year.
Who's Hai?
Haibing is
A student who's a really smart guy. No, really
oh,
smart
okay,
guy.
sorry. Sometimes I say people without actually explaining who they are. So Haibing was the other student. Remember I said I had year 8 and year 9? He was the other one. And he stayed with me for year 10. Yeah, he went to your brother's school,
Wait, what
James.
about?
James Roos.
Oh,
Yeah.
question 9 and 10.
He went represented Australia in AIMO. He got a silver medal. So yes, and this was the first time that this was the last time he did this test. So so he went so in year 8 he got a participation. Okay, so that's less than 3 questions out of 10.
What about
Okay,
year 9?
year 9 he got a prize. Year 10 he got a prize.
So you improved a lot.
Yeah.
1 year he went to a participation.
Yeah. So he met me in year 9. Okay. So okay, if you look at the stats, 1,415,
208.
and then it's 1,869, right? So 450 people, okay, did not solve question 1. You understand?
Oh.
450 people, they might have gotten 1 mark, but they didn't get 2 marks. Yeah? Okay. My question is, how many of those 450 people do you think legitimately left the exam thinking that they didn't solve question 1?
Yeah.
Right? These are people, like, these are the top AMC scorers from their school who are even allowed to do this because their school has weird policies, right? Probably all of them thought they got it. Okay? So the point I'm trying to make is you got to check your answer. Okay? Right?
But what if it's not checkable?
Yeah. Well, this one was, yeah.
Oh, true.
Okay, so if it was not checkable, I could maybe understand this number maybe a bit more, but the fact that and also maybe it's also possible they're all like in year 1 or something, but it's unlikely. Okay, what's the total?
Year 1.
So 500 in year 10, 500 in year 9, 500 in year 8. So basically 350 people 7 and below. Yeah.
So year 1s even do this test?
I think in the very extreme case. So like there's a guy on the Australian team right now. His name is like William Cheer or something. I'm pretty sure he did this in year 1.
What he did? But he got participation probably.
Yeah, he had a very steep learning curve. So like he started probably doing pretty well by like year 3 or 4. Like he was, yeah. So some people start very early, and they're also very gifted as well. So, um, yeah, I don't actually know the stats on that, so I don't want to talk too much about it. But it's kind of crazy here, right? Almost everyone didn't solve this question.
Yeah.
Almost everyone. It's like the opposite of the first question, yeah? The people who didn't solve the first question solved the second question. Okay.
About 80-something% of people didn't solve this second question. That's crazy. Can we do question 2?